And hello, today in the workshop I've got a Peavey amplifier. This one's 4000 watts. This is a bit of DJ equipment that's had a bit of DJ abuse. Let's have a look. And like most professional amps, there's not too many controls on the front. There's more controls on the back. We've got some hidden little switches. The switch is where you set the mode, so this one was set in in parallel. Wow. Someone wanted to get the very maximum power out of this thing. Just going to power this thing up using the restricted power supply, never mind the wiring. Well, there's lights on that shouldn't be and lights not on that should be. And there's also a horrible burning smell coming off here. Oh crikey. We'll turn that off. There's a lot of screws on this as well. Hooray! At least they're little self-tappers, which come out quite quick. And then this bolt out here. Bizarrely I'm having to use an 11mm socket, because it's not a 10mm. I don't know what size that is. Be some imperial thing I'm too young to know about. What will we find inside? Oh, this has had a bit of trauma in its past. Oh, look at that! Huh. It's a former patient of this very workshop. Last in good 3 years ago. I have to look up what happened last time. But I am seeing blown up parts. These inrush thermistors shouldn't have big chunks missing out of them. Yeah, something's seriously wrong with this. Well, as I've had this before, I've probably marked up all the connectors, so I think I can just start yanking them out. Did I mark them? Oh, at least I'm filming it. Pull the mains cable off. Just a little earth tag down there to release. Get the screw, don't want to lose that one. I think this board's only held down by 3 screws. Oh. One that side, this one on the right, and right in the middle of all these caps. If I remember rightly, this board won't come out with the transformer in the way, so I'm going to take it out. But it's really heavy. They weren't thinking about me when they designed it, were they? Anyway. Oh God. I've got the awkward part now. I don't want to let it completely go. Just got to balance it right on the edge of the desk. This bolt feels very long. There goes the washer. That can at least wiggle a bit. It might lift it out. Well, let's disconnect this cable tie. Right, disconnect. I mean chop off. Let's pull this out. Oh, I didn't pull it by its wires, did I? Yeah, don't do that. The board's held in these little like key-shaped things, so in theory you just pull it towards you and lift it by the handles they haven't provided clearly. And it still doesn't want to come up. This board's just trapped by everything. These bits of card, these air sort of guides. Even the main switch is in the way. I don't know what they intended when they designed this. You have to just Surely they don't want to bend it. Oh, there we go. Crikey. God, are you supposed to do this? Oh, and this is an amp I've had apart before. I don't remember struggling this much with it. Well, it's all very dusty as normal for any DJ equipment, and fluff stuck in the heat sinks. I'm going to take these heat sinks off actually, because I can't really see a lot of this at the moment, and they also have quite a lot of weight on there, so I'm very worried about this board just folding in half and snapping. That'd be a bad day. And of course, all Torx screws, which, to be honest, are a better screw. Wish I had some sort of Jedi powers to make screws disappear. Well, I'm pretty sure everyone watching this knows that that's not a good sign. Yeah, it's not just Han Solo who's got a bad feeling about this. Well, you can sort of see the where the blasters come from is under this heatsink, and it looks to me like the legs might be blown off that transistor. Well, I don't know if it focuses on these bits under there. It's not just the camera that's out of focus, I think the world underneath here is out of focus really. I'll just take them both off because I might need to read the part numbers off these ones. Oh, well, it does have all of its legs. Yeah, it is definitely blown up though. I'm not a fan of this layout, lying face down. I mean, I get it, it's all low profile and makes the amp nice and flat, but what a nightmare. Nightmare to work on. And all this heatsink compound everywhere, it's really messy to work on, so I'll have to clean that off. I can tell you, if you get this on your clothes, it doesn't wash out. Okay, let's start assessing the damage we can see. These two things are IGBTs. These are transistors which switch the levels to the output transistors. They're a bipolar transistor with an insulated gate, however that works, but you'll have the gate here, then the collector is on here, then the emitter. This should be open circuit, and it's short circuit, dead short, which is not a surprise with this burnt leg. This other one looks alright. Okay. Yeah. And we can also check these diodes here. That's a good one. And this one. Yeah. Those bits are fine. The output transistors are actually all in parallel, so you can actually you can just check across them all in one go. So from the collector to the emitter. Yeah, this one's fine. This whole set will be fine because of that. And same here. Collector to emitter. Actually, I better unsolder that shorted transistor because that's going to really confuse all the readings. Lively. I didn't expect that across a shorted transistor. I got a discharging tool, which is a good thing. I should remember to use it. Oh, decent voltage there. Anyway, where were we? After that bit of excitement, we're just lifting this out. Now that shorted part's been removed, I can check all these transistors. Now on these, all the collectors and the bases are common. So we got, that's the base, that's the collector or the tab. So the emitters here need checking. So from this one, that's a good one. This is good. This is good. Also good. That half looks fine. So we'll do the same here between this and the emitter. No, the emitter's this side. Well, they look okay to me. Just have a general poke around anything that's lying about. This regulator here. That seems a bit odd. That's knackered. Let's take that regulator out just to check, because it could be a short across something it's supplying. It's a bit warm. So if we start labelling up the schematics and just mark on what's damaged where. So Q131 went short straight across there. So that's the first problem we've got. And I also found out a regulator, which is IC203, which is probably not on this page actually. I think it supplies a low voltage rail. Yes, down here, IC203. That's damaged. But from what I can see, IC203 drives the fans. How strange. I wouldn't have thought that I'd had anything to do with the problems this has got, but maybe. If it's got too hot with no cooling. Just check the one for the other fan. Across there. Yeah, there's no problems here. That's a proper reading, that is. Just have a poke around the circuit that drives this blown up IGBT. Part of it, there's this Zener diode here, which is fine. Well, it appears to be okay. Let's check some resistances. 22 ohm resistor. It's spot on. What's this supposed to be? That's not how you measure it. 4.7k, yeah, that's fine. This capacitor here, just check that's not shorted. 1.2 meg. Yeah. You tend to find with these things, when the surface mount resistors go, you can see it. Like this one here. This one's got a blister on it, should be 2.2k and it's measuring 1.8. Really? 1.5? Very close to this transistor here. That looks alright. Oh, 2 ohms. It's not alright. Right. Let's write that one down. Q102. Q102 is here. And those resistors, the 2.2k, that's blown as well. So, I'm starting to get a picture of the damage. Actually as well, I'll get the hot air gun on this. Get rid of these shorted parts, because like I say, they throw all the measurements out. And this will probably take a while to come off as well. Apart from that one, came off rather easily. Just check what size resistor that was. A handy little tool. I think it's a 2512. Oh, no, it's smaller. 2010 maybe. So just start marking some of these parts on the we tested as good, so that diode was good. All this round here is fine, which makes me think that whatever caused it might just be just overload, and it may just be something connected to the speakers maybe that shouldn't be. What about this diode here? Yeah, if that's gone, that would have taken that out. D197. That's just down here. 0.4 volt drop. Yeah, it's alright. I should check out where the minus 18 volt supply comes from, because it may have been damaged. The minus 18 volt rail comes from IC303. Where's that? Oh, down there. There it is. Bit awkward to get at. I'll just check for obvious shorts initially, just to it looks sensible sort of measurements. Nothing looks burnt up around it either. Yeah, I think it's okay. Oh, hello. Cap's missing. Where's that gone? Yeah, it's never a good thing. What's that? C404. It appears to have fell off the board, and it's close to this rail. Just referring back to the drawings, I'm just I can't see a correlation between a short circuit over here just finding its way to damage this. Not straight away. If none of this is short, what could it be? Maybe if I follow it from here. So if this hasn't damaged that rail there, or that one there, it looks okay. Maybe we've got trouble here. So this IC100, where's that? And of course what we appear to have is, there's a channel here, channel B, channel A, and then all the controls are right on the edge over here. So we'll spin this around. Have a closer look. And I see burnt resistors right next to IC100. Oh, these all look a bit dicey. Oh, and over here. Yeah, I think I'm going to move to the other bench, because this is getting a bit small and I need the microscope. Here's IC100, and it's got some damaged resistors. I think this is where the energy went. Yeah. Yep. That's gone. That's gone. That's got 8 meg, blimey. Completely gone. Back up here. Yep, that's gone. What's this one? That's okay. This chip contains 4 transistors, and I'm going to say that they are absolutely goosed. More worryingly, they sit between 2 more transistors, which are over here. Let's have a shuffle across. The transistor array is suspended between these 2 transistors here, and I can see burnt resistors again. Yeah, they're also knackered. So these transistors, I think, so that's base, collector, emitter. Are they short? That one looks like it might be okay. And this one is 2 ohms. Yeah, that's knackered. Which one's that? That's Q105. Well, now we've established that, might as well remove these dodgy parts off here. The hot air gun, weapon of choice. I can just see the old flux starting to bubble up. This may be exactly what happened to it 3 years ago when it first died. That's off. Whilst the board's hot, we'll do the others. I just took that one off, there's nothing wrong with that resistor. I'll desolder these 2 as well. Got holes blown in the tops of them, look. You can see little dimples here, or you could. Like there, where the meter probes went in. Patience is needed. There we are. Let's get these big transistors off next, so just move that out of the way. Right, to get these off, I'm just going to sort of flood them with solder. Warm all the pins up together. There we go, comes out nice and easily then. Same with this one. That's getting a bit too hot to touch. Might be better off just cutting the legs off it. If he's going to mess me about. Just fish the legs off. Clean the holes out. Oh, that didn't work. Oh, we're having a bad time here. Got a bit of pad damage there. Have a look if that matters. Probably be okay. Tend to find if the pads just peel off that easily, they don't actually connect to anything. Just going to assess the pad damage now. Just clean it up. It's difficult to see with the black solder mask. I almost feel paranoid that they do this deliberately to make repairs awkward. What we got is here. That's fine, that's connected to there, and this one's all good. That pad's there is fine. This one here is half intact to there. This one, it's smooth as well. This doesn't go anywhere, so although the pad's missing off the top, it's not a problem. Unless it's missing from the bottom as well. Yeah, there's two pads ripped off here. Fortunately, it's the opposite way round. So, yeah, it is a bit chewed up though. That one's a little bit, yeah. The through-hole plating's still intact. Now that's encouraging. We've got away with that. It'd just be a little bit awkward to solder. Just focusing back at Q131, which is the IGBT transistor that blew up. I can see why it didn't take any fuses out. It's because the track's blown off the board. I'm going to clean that up a bit. It's pretty charred and ruined. Some of the carbon that comes off here is conductive. If the voltage on here is high enough, it might travel across this carbon residue on here. Definitely a problem with old like monitors and HT circuits. Yeah, you can see here that the track has acted like a fuse and disappeared. So I'm going to have to scrape away a bit of the solder mask, this black part here. Try not to tear it off the board. Just going to clean that up with a fiberglass pencil. Which is very good, but it's a dreadful tool because you get little bits of fiberglass that always end up stuck in your fingers. But that has cleaned that up beautifully. I'm happy with that, so we can look at some sort of repair on this. Looking at this other pad as well, just to see that it's in good condition. Might need to perversely add a bit of solder so I can remove it. That's nicely tinned. Find this soldering tool. Oh, this doesn't work very well at all, does it? Fortunately, the centre pin of this transistor only goes to the top layer of the circuit board, so I only need to repair the top because I don't actually know if the wire is intact or not, but it doesn't matter as long as we're aware of it. To fix the top track, I'm going to use this copper tape and cut a shape out that sort of fits and stick it down, then solder it on and hope it holds. I'll put a little dot where the hole should be. That's about it. Then I think I'll solder it on first. I'm just going to stab it with this. There we go. Now that's about it really. So I have the new transistor, and here it is. I'm just going to slide it in there, make sure it sits flat and that the hole lines up. Let's just check that. Be a disaster if I got that wrong. Yeah, that's okay. That's okay. Let's go for it. I'm going to do the end pins first because they're not so delicate. I'm going to push that back a bit. It won't hurt to get extra solder on here. And I'm sure you can hear that helicopter flying overhead. There's actually an air show on today. I live about, I don't know, 5 miles away from Cosford Air Force Base, and they are doing the air show. First one in 2.5 years because of the pandemic. And it's right up there. Yes, looking again at this area where this 2K2 resistors burnt up, but the underneath the board's actually burnt as well. It's not burnt this side, but it definitely goes underneath there. So I want to fetch that perfectly good resistor off, just so I can check the board underneath. Yes, and it's a little bit charred. Well, that does not look brilliant, especially where the pad's twisted around like that. That's definitely not ideal. Sit back down. The black solder mask makes you think this PCB material will actually be black, but I don't think it should be. It's like typically be a light colour, so I think this is charred and probably conducts a bit of electricity. Yeah, so this blade, I'm going to put some, see if I can dig out this charred mess. I think that may be it. I think what I'm going to do is use some epoxy resin to fill the hole in, really, like a pothole repair. If it will flow nicely, I'll give it a dab. I'm not that patient. If I get this right, it will stick the pads down as well. It's difficult to tell if I've got this level or not. In fact, no, I haven't. No, it's not level. Dig a little bit out. Hope it flows back, because this thing's going off all the time. It sets in 5 minutes, so yeah, let's not faff around here. If I can bend that back down, just to touch it but not push it in. I should probably leave well alone right now. Okay, we'll go with the little transistor. Just tack it on there. Right, whilst I leave that in to dry and do whatever it's going to do, we'll move on around the board. So the next part was the capacitor that fell off, and God knows where it went, it's vanished. I've got a new one here, so I'm going to just fit that. I was going to clean these pads up, put some fresh solder on. Just give the area a bit of a clean. Fresh flux on there. We'll see how it sits on. So we'll just go in with the iron. Let that sink down. Still working around the board in a clockwise direction. We're now on to replacing some burnt resistors. These are little 1206 size surface mount ones. There's much smaller ones, but these are still a bit of a faff to fit. Or at least getting them out of the packet is always fraught. There we go. Tip them out. We'll keep them safely nearby. Put them the right way up. It doesn't bother the electricity which way up they are. But it bothers some people, I tell you. So like always, a bit of fresh solder on there. Just a little bit of flux. And we'll just tack these on with the iron. I don't care which way up they are. And where's the other one? Over here. So Q105 at the top there with the dodgy pads is a 2SA 1837. One of these. It's worth checking if these transistors are real, because they're obsolete. With all the stuff going on in China at the moment, you end up getting these things on eBay, which is always a little bit iffy. There's a lot of genuine businesses on there, granted, but you never quite know. So these things are rated for 230 volts, 1 amp. I'm going to see if they can actually handle what they say. This machine's heading on for nearly 60 years old now, but it's very useful. It's a Tektronix curve tracer, which is basically a lie detector for transistors. It certainly sniffs out any fakes. So to use this machine, we put our transistor in the test socket down there. Just pushes in. And we simply turn it on. In this test we're going to look for the breakdown voltage. So turn it on, see how we go. So that's 50, 100, 150, 200, whoa, 250. This is supposed to be good for 230 volts and it hasn't broke down yet. We'd know if it had because the line would go vertical. If I carry on we might encounter that. No, we found the limit there. I'm happy that this doesn't have a problem with the breakdown voltage. Just going to fiddle about some readings. I want to do another test on this and just see how it works. We can put a few steps on there, say 5 steps. Let's pull that out, turn it to 2.2. Drive a bit more power now, up to 10 watts in there. A bit nervous about blowing it up on the test bed, but there we go. Then we have the sort of typical curves you might get off these things. This is looking quite genuine. I mean, we're only driving this at about 25 milliamps at the moment. It's rated for 1 amp, but you know, we're also driving this up to, you know, this is now 200 volts across there. Well, there it is. Yeah, there's a bit of heat on there. So that one, I believe, is genuine. So we'll try its complement, the 2SC4793. Just pop that in the test thing there. This is an NPN transistor, so I'm going to swap a few things around on here. To start off, we've got to go NPN there. Then we'll have to uninvert the display. Uninvert that. Now it's good to go. Let's give it the test then. So we're going to go up. So we've got a 20, 40, 60, 80, 100 volts, looking good. 120, 140, 160, 180, 200, and then it goes off the screen there. There's 220. Yeah, there's nothing wrong with this one. This is also looking pretty healthy. So, I think these are genuine. So that'll sit in there. And this one sits there. Well, there's only one pad on this one here. So we've got that one. They're in. To solder these from the top because the pads are missing off the bottom. Right, solder these resistors on. 510 ohms right at the top. Yeah, get both ends in. Another 510. Now a 49.9 ohm resistor. Strange value. And there's 2 of them. Needs levelling up a bit. I'm just going to dip the chip on top of the flux just to get some flux on the chip's legs. Then I'm going to go with hot air with this one. Some of these pads are connected to ground and all the heat gets soaked away. It can take a long time to heat these up. And these are resistors to sit on top of the pothole repair. Oh, where'd that go? A little bit of flux. Let's get this on. Nice and easy. Big resistors solder on quite nicely. Lovely. Let's neaten that up. Oh, oh no. What have I done? And here. Oh, what is wrong with me? Come on, sit straight. I'll blow down the board. What's next? Oh! A few too many. We only need the one. It shall have its leg bent. Something like that. It's about time for some heat sinks to go back on, so just put a bit of heatsink compound on. Just checking there's no sort of damage on here. Looks okay. This heatsink compound's terrible stuff. I'll try not to touch it. There's probably a special tool for this, but I ain't got one. Board flipper, turning over, I don't know. Make sure I put loads on for the next guy to get all over his top. Check out my alignment here. There's a lot of screws here. Well, I think that's ready to try out now. It's a difficult to handle, it's a bit bendy. Just trying to line these up all over the boards and just give it a little push. That's locked in. There's only a few screws to put this in with. It's about the only part of this amp that's quick to do, I think. One right down in the centre. There's this bolt that holds this transformer in, so I'm going to pull it back over the bench so you can get to the bottom. There. Give it some inputs. Maybe a bit premature now, but see how this amp runs. So here it goes. Oh look, there's output on both channels. Well, that looks prepared now, doesn't it? Well, that's good enough for me. Put it back together now. I'll put the lid on, but just checking that it's got these insulated cards on there because they're needed because the heat sinks are actually the output on this amp. So if you didn't have the card, you might short them out, which wouldn't be very good. Well, that was a really irritating repair in the end, mainly frustrated by a lack of parts. Just a world we're in now. Catch you next time.